guys. Thanks everyone for being here. I think, most people in this room have hopefully heard of Doublezero. But yeah, I mean, I don't know, Austin, if you want to give just a quick TLDR, maybe starting with like the vision of why you felt compelled to, leave Solana Foundation, embark on this new project, and then we can get into the weeds about like what it actually is doing.
Yeah, certainly. So Doublezero is at its core a physical fiber network dedicated to high performance distributed systems. And it's kind of a weird project to be talking about in the sense of like 99% of things in crypto are software layers, right? This is like the whole promise of crypto is software abstraction, software systems that allow us to do things not previously possible. But you get to a place pretty quickly in pretty much every tech company, going back as far as you can define tech company, you get to a point where everything trying to do software needs to look at hardware. And they need to look at hardware because these type of systems are always limited by the physical layer and the physical systems they're running on top of. And so you see this having taken effect in traditional tech companies, that Facebook got to a size where it had to wire up the Philippines with fiber optic internet to sell people ads, right? That was where they reached their growth trajectory. And crypto, honestly, is there. Solana is, by orders of magnitude, the fastest network for the number of validators that it has. Right? You can think this, it's kind of a ratio. No one's like put a definition on the name of it, but like Ethereum has more validators, but it only does 14 things per second. There are networks that do similar transaction volumes to Solana, but they have a 10th or a 20th or 1/2000th the validator network size if they run on a single sequencer. And so Doublezero is kind of a wholesale rejection of that future that says we either need to crash the validator set dramatically or we have to be roughly content with 10,000 TPS forever. And we just think that there's fundamentally a better way to do this.
Yeah, and so, I mean, I think the most tangible benefit that people can think of is the fiber. I think there's a couple other benefits that we can get into, but I mean, maybe starting with like, what does it look like today for a validator in Tokyo to communicate with the rest of the cluster in Amsterdam, and how do you guys envision improving that?
Yeah, so you might think the public internet is like this really fast, incredible thing, and it is this incredible thing, but the public internet is built for reach, it's not built for performance. And so if you are operating on, let's say, a validator in Tokyo and you're trying to talk to a validator in Amsterdam, there's a whole bunch of hops that your data takes along the way to get there, and it does not take a straight line path. You might think, oh, there's a cable that runs from, Tokyo over the top, then goes down into Amsterdam. And you're right, there's actually several cables that run nearly directly. The problem is those cables aren't what you're being routed over on the public internet. You're being routed through a whole system that's been built up over the last 30 or 40 years, which is designed pretty much for maximum reach and not performance. And the business incentives are not to give you a high performance experience. They're to basically zero rate the billing across your competitors. And so you will find that when data is moving from Tokyo to Amsterdam, in this example you give, it's going in a very indirect route, and it's running into basically queuing. So it's like merging onto a highway. The speed of the highway traffic slows down, always, right?
Yeah.
And so you run into these systems where you're stuck in basically a packet queue, sometimes for up to a second or more. And this is called jitter. Jitter is the measurement of time it takes data to get from one place to another, averaged over a standard period of time. So you might say the ping time is maybe 200 milliseconds, and ping time and latency are the same thing in this case. But sometimes it takes 200 milliseconds. Sometimes it takes 250. Sometimes it takes 190. Sometimes it takes 470. And that sort of on-off again latency, that indeterminate nature of networking over the public internet, it's a real performance killer for high-performance systems. That is the single biggest problem, because suddenly you think about this, all this data is arriving out of order now at the validator, or if not out of order, it's arriving in very like stop-start intervals. And so it means you have to stick things in caches and queues, and you have to basically reassemble the data as it comes in, and sometimes it comes in out of order. And that can cause real problems when you're trying to move systems at 400 milliseconds, let alone 10 milliseconds.
So do you see the jitter reduction as actually the more impactful benefit in the near term relative to the latency?
Yeah, I mean, if we just look at Solana today, latency is a limiting factor if you want to run a node in South Africa or South America or Australia. It's not a limiting factor for basically the northern hemisphere, right? What is a limiting factor is jitter. And so today, if you look at the network, jitter is one of the main performance characteristics we can improve. That'll reduce skip rate, that'll improve transaction deliverability. It'll basically make the cluster able to move a little bit quicker than it does today. But we're not just building this to have more fiber connected between folks and have lower latency and lower jitter. We're doing this so you can go from 50 million CUs to 500 million CUs. And we can keep 400 millisecond block times. We can massively scale what's available on Solana by basically saying, look, the public internet is not going to be our limiting factor in scale. Because we could keep the public internet as a limiting factor of scale in Solana, but one of two things are going to happen. Either this is Solana's Ethereum moment and it just says, we're never going to get any faster. This is it. Or you start to see everyone move to Amsterdam, right? There's the two models of the world. There's the Ethereum model of the world and the Hyperliquid model of the world. And that's kind of the only two options today. And if you don't address the lowest level of the stack, which is the physical connectivity between different systems around the world, you're just stuck with those choices. And I think both of those choices are not great.
Yeah, and I mean, I think you and I care a lot about kind of the underlying technical details, but I mean, Solana, right, is a user-centric chain. That is the beauty of it. Like, if I am trying to ape Farcoin because I think something crazy is going to happen with Trump and it's about to bounce, like, how does this impact me as a user of Solana that the jitter is reduced, the latency is reduced?
Yeah, so you'll see, like, a bunch of different things take place during periods of congestion. So, like, let's take the non-congestion start, because I think that's, like, probably maybe a little more interesting, actually. So the amount of time it takes when you hit send on Phantom or Soulflare or whatever you're using, that data has to run out to an RPC server, then it has to run from the RPC server to the leader. And that's like in the most optimistic case. Sometimes it's actually running to catch up with a leader. Maybe it's running through a Gito block engine, right? All of these things add latency in the system. And so one of the things you're able to do in markets that move faster and they move with less latency and less jitter is slippage goes down, because price discovery is now more immediate and markets are responding with faster, better data and better availability. So we will probably see slippage drop on Solana a little bit, which is good for everyone who's a retail trader. We'll also see that, like, the situation you have sometimes of like, oh, a market has moved and like my front end didn't realize it. That'll like be a much more addressable problem. The other one really is like when you're trying to pull fresh data, there's sort of like two sides of this, right? From a user perspective, there's, can I write data to the chain more quickly? And the answer is yes. The other is, can I read data from the chain more quickly? And we don't spend much time on this. Like, I think Max said a tweet earlier today that's like, the state machine isn't the problem, it's data replication. And that's 100% right. Even the centralized sequencers today in the Ethereum world, they have a massive problem of they just can't get the data out to the RPC servers fast enough. And when you can't get the data out, like, you can think about this as like there's a propagation rate. And I know we're getting a little away from users, but there's a propagation rate of data coming out of any central system. And you're basically limited by the light cone of that data. And if that data is not getting to you quickly, it's as if the block didn't even get produced, right? Now, for traders who are co-locating and that sort of thing, they kind of get this exponential multiplication effect where they'll be able to be faster than users again and again and again when the data hasn't fully propagated out. And so if you really want these systems to not fall into the same problems of TradFi, which is unless you pay a huge amount of money and have a server co-located at NYSE, tough luck, right? You're never going to beat the traders. And even if you are doing that, you don't have the fresh arbitrage data coming in from all the other exchanges to be able to have the best price predictions. I think it's really important that we look at this stuff at a very base layer and say, if we really believe that one of a property of a blockchain is economic fairness, not that your transaction and my transaction are treated equally, but we have the same ability to pay for prioritization and therefore have our transactions be treated equally. We have to really think about data flows both on the ingress and the egress side.
Yeah, and I mean, for context, I think people may be surprised. What is the lag? I think everyone probably knows Solana is 400 millisecond blocks. Transaction can land very fast. If it's at a Helios or a Triton RPC and then it's submitted to the leader, that is actually turned around pretty quickly. But what is the lag that people experience on the other steps of that on a relative basis, right? You have the front end, you have the wallet submission, then you have the read layer to actually get the little pop-up that says your transaction has been filled.
Yeah, I mean, this is the stuff that people don't think about as much. By the time you've gotten a transaction to a Jito block engine, you're pretty close to there, right? There's 8 of them now.
I think 5 or 6.
Five or
Maybe
six.
I think with the London one.
And so they're pretty well located around the world that you have good distribution relative to stake. The real long time is everything else you talked about. So just because your RPC has received data, right? So Jito runs a whole program called ThreadStream, but there's lots of other systems out there where a block is produced by my validator, and then your RPC gets it. Well, your RPC now has to read everything in it, add it to its little database, and figure out, okay, well, when someone requests data, now I have to send this thing back out. So we can easily, when you're looking at data on a front end or data in your wallet, you can be looking at 2-second old data, right? And that is a lot of blocks at this point, right? Yeah. Especially because Solana doesn't, everyone's 400 millisecond blocks on Solana. Solana actually has much shorter confirmation times than that. If you use the Ethereum language of pre-confirmations and other types of church Latin, Solana, basically every shred is a pre-confirmation, right? Once a shred exists and has been created by the block builder, it's not voted on yet, so it's not, finalized or confirmed in that sense, but you can't undo a shred unless the entire block fails. And so you effectively have pre-confirmations in Solana every 15 milliseconds or so. And what that means is when you're, if it takes you 2 seconds, you've actually not missed 4 blocks or something like that. You've actually missed significantly more than that because the ticks or the increments for which a market moves are actually many times even within the same block.
Yeah, no, it's many multiples the outside of the blockchain world relative to what actually happens on the blockchain. And I mean, the user experience there, Solana is already fast, but if we're able to optimize that, it is going to feel much closer to a centralized exchange experience. And I think that's really exciting.
Yeah.
But I mean, I guess zooming out a little, you touched on the northern versus southern hemisphere divide. And for context for anyone listening, there's almost no stake in the southern hemisphere at the moment. There's quite a lot in Amsterdam, quite a lot in Frankfurt. Tokyo is also very popular, a good amount in the US. But how, I think the core vision of Doublezero is probably IDRL. But how do you guys fit in geographic decentralization? Is that a priority of yours? Is it from a commercial, a value standpoint?
Yeah. So let me start off by saying we want more fiber globally connected, and it's in our best interest to do that. And it's in, our best interest to convince people that they should do that. But maps lie to you all the time, right? How many times have you looked at one of those maps of what counties voted which way in the United States, and you're wow, it's 80% of the country votes red. And you're well, if you treat land as voting rights, sure, but land doesn't vote, people vote, right? So 70% of the world's population is in the Northern Hemisphere, and most of its economy is in the Northern Hemisphere. And so this is not to say anything bad about the Southern Hemisphere, but there are a lot of reasons why systems are built this way, because people build around economies and they build around population centers, right? And so when we kind of ask what is fair geographic distribution, it's a very hard question to answer because it's not one-to-one. It's not there should be every square meter of the world should have equidistant to a validator. That would put a lot of validators in the middle of the ocean, and I love fish, but they don't have wallets. And so a lot of these questions get very complicated in terms of what is good geographic distribution. What I'll say is there's some things that are not our problem yet. So communication between Buenos Aires and Cape Town, you would think would be pretty good. They're fairly close to one another. Turns out, if you want to get from BA to Cape Town, your data is almost certainly going all the way up to New York, over to London, and then down a cable along the side of Africa. It's not just going, oh, look, there's a nice little hop here we can do. And so some of this is like the way that physical infrastructure has been built reflects the way that economies work in the outside world. But there's things like TVCs, timely vote credits on Solana, that impact penalties if you're not voting in a certain period of time. And there's some of these things that are the only way to solve them is with dedicated fiber. Like the public internet is too slow to run a validator in Cape Town. It's too slow to run a validator in Sydney. It's too slow to run a validator in Buenos Aires. But with Doublezero, you'll be able to do all of those things because we'll have dedicated fiber that's much, much, much faster. Now, it's entirely possible the Solana protocol says, great, now we're going to go to 300 millisecond block times and kicks all those validators offline again. But, the other way to look at this too is if we can start, there's like a magnetic center right now that's kind of around the Central European corridor in Amsterdam. And you can sort of think about it as like, how much suction power does that system have? And right now it has a lot, in part because of TVCs and bad public internet. And so we see stake kind of moving towards those areas. But we can sort of reverse the polarity, for lack of a better term, if you can make it possible to run validators in wider areas. That stake centralized distribution just needs to expand just a little bit. If we can push 2% more stake into Southeast Asia, if we can push 2% more stake into Tokyo, if we can push 2% more into somewhere like Mexico or even, Dubai, these places like Israel, if we can start pushing stake a little bit out of where it currently is located, a lot of these areas get much more viable to run validators in, even without Doublezero. And so our hope is what we can do is make it more profitable to run them actually outside of the core. And the reason, and you might ask, why would that be the case? Well, suddenly we now have arbitrage opportunities to centralized exchanges that didn't exist before, because those centralized exchanges are not in Amsterdam, right? They're not necessarily in the area where the core of stake is. And so we can use economic opportunities, especially as stocks and equities get tokenized. There's going to be a lot more arbitrage between centralized exchange systems and decentralized systems, and Doublezero will have plumbing into all of it. So the fastest path between the Binance order book and the Jupiter, well, not order book, but Jupiter aggregation system, will be through the Doublezero network.
Yeah. I mean, Toli's classic example of like crazy news happens in Singapore. How fast can that be reflected in New York or Amsterdam where stake is? And that's something that we should really think about. But I think that is very concrete. Like this connectivity, everyone has a mental model of it. I think there's other benefits to Doublezero that are much harder for the average person, and they may not even be aware of. Right? They just think you guys are like, getting good fiber. So do you want to dig into a little, like what you see as the other key benefits?
Yeah, so one of the cool things you can do with a network like Doublezero is you can use technology that just is not available on the public internet. And so one of these main pieces of technology is something called multicast. And you've probably run into multicast in its residential application before. It's how AirPlay works or Chromecast works or Sonos speakers work, where you can send one copy of a song from your phone to 6 different speakers at a time. That is using a technology that basically replicates packets at the network level. So your phone is not sending out 12 copies of the stream. That would probably start overheating your phone pretty soon. It's sending one copy, and your Wi-Fi router is sending it to all the places it needs to go. You can't do this over the public internet, but turns out you can do this on a private network just fine. And you're not doing it with audio data anymore. You're doing it with replacing Termite, with Solana state propagation, switching to this multicast technology. And suddenly, it's much faster for validators and RPCs and indexers to get state updates. It's massive bandwidth savings, all sorts of different things that you just can't run on the public internet today. Another big component for Doublezero is we've integrated FPGAs, field programmable gate arrays, into these actual network devices. And so what this allows you to do is it's very cool. So FPGAs, they're not quite as powerful as like ASIC miners or something along those lines, but the nice part about them is the programmable component. You can load different images onto an FPGA and it can do different things. And so it's sort of like you can define a CPU, a custom CPU, to do custom things in software. And so right now we are using FPGAs on Doublezero to do signature verification. So if someone's spamming the network with a bunch of stuff that fails signature verification, the FPGA just throws it out. If someone's sending a bunch of duplicate packets and trying to do a DDoS attack, the FPGA just drops those packets. And we can do all sorts of other things like implement quality of service guarantees and all sorts of other things in the future using these as well. But these are sort of like concepts of resource sharing and shared defense. Right now, every validator gets the full front of the public internet every time it's building a block, which is part of why things like Jito are so popular and things like stake-weighted QoS are fairly popular, is they provide some level of like Sybil resistance. But during the DDoS attacks on Solana, we've seen over 80 gigabits per second targeting a validator, and that's going to kick any validator offline. The FPGAs that we use can dedupe at 100 gigabits per second and SIG verify. And so that means that suddenly, if you're getting over 100 gigabits per second of an attack on a server, the data center is going to start noticing, right? That's a problem where suddenly the place you're running is like, wait a minute, we got to figure out what's going on here. This feels like an attack.
Yeah.
And so a lot of these technologies just are not available on the public internet. And so our goal and our vision here is that we can bring the best of private networking technology that's really been pioneered by high-frequency trading firms and Google and Amazon and all these other groups to the blockchain industry.
And how do you think of, like, if you're pitching to a validator or a network to get set up, I mean, how do you think of the benefits? Is it right now mostly the fiber and then the networking is kind of a nice to have? And is that going to evolve as just we see Solana mature where blocks do actually increase? There's a lot more data that needs to be connected.
Yeah, so I mean, Anza has already publicly said they're committed to getting Solana up to 100 million CUs by the end of the year. So
And what is it today for context?
50. So 50 million.
As of like a week ago,
As
right?
of a week ago. It's been 48 since basically network genesis. And the cool thing about this is it means there's more data and there's more stuff for validators to do. And so validators will also get more block rewards by doing this. But this is a situation where like crypto sometimes can be very parochial. It can have these like very small-minded views on things. And, validators and stakers, like quite frankly, need to realize that if Solana is to maintain competitive, we need to switch from using the public internet to things that allow it to move much faster than it does today. And there's two ways that can happen, nicely or kicking and screaming. Right? Like the devs working on Solana and Firedancer and the Jito client are not going to stop. And so what we want validators to say, okay, like we want to connect into, private fiber systems. We want to connect into Doublezero, and we're willing to help pay the cost of that. These systems are very, very expensive, and this is why it's a token project. I get asked all the time, like, oh, why is it not just a fixed fee of like, certain amount of money per month? And it's like, well, then we'd be just building the public internet, right? And that's not what we want to do. We're building systems that are much more high performant, but that means they're expensive to run and operate on. The trade-off here is basically like operate on Doublezero. There will be a little bit of cost associated with doing that, but if we can make the validator network 50% faster, you're very easily in the green. If we can make the validator network 500 times faster, right? These are win-win systems that require some coordination and investment. And we don't have any grant from the Solana Foundation. This is a not a project that has like Firedancer money behind it or something along those lines. This is something where like we're really trying to do this in a way that is an independent entity, an independent organization. And so this is why we're really excited about the work we're doing with Jito to like try and make blocks built through Doublezero more profitable. Increases when you decrease latency, you increase MEV opportunities. There's a lot of cool stuff that we'll be able to do towards this. The pitch for validators is basically like we want to build Solana 2.0, and we'd love if you're interested in being a part of that.
Yeah, and a common kind of question is that Solana is known to, whether you call it a bug or just opportunity for optimization in the software, and particularly Firedancer is vocal about that and just like how much potential there is in the current architecture if things are done differently. It's like, how do you think today of what, there's like, people will be like, oh, we'll just throw a bigger box at Solana and we'll do more. And, a common pushback is like, well, we don't need bigger boxes. We just need to fix some of the bugs in software that are massively inefficient. But like in the realm of Doublezero, whether it's networking and fiber, how much of this is fixable with software optimizations versus necessary at the hardware layer?
You can't fix physics with software. right? Like, I think that's the big takeaway is, like, if we're doing this correctly, we're going at it from both directions at the same time. We're saying that we're going to have faster physical connectivity, which the software will be able to be optimized to take better use of. If you're at Breakpoint last year and you saw the million transaction per second demo that FireDancer gave with, I think, 6 nodes on 4 continents, that was running on the Doublezero network under the hood. That demo would not have been possible on the public internet. And so, like, if you look at like what's kind of happened in the Ethereum world, there's been this like, oh, we'll decentralize it in the future. Don't worry, we'll get there thing going on for like 5 years with L2s, right? And there's still no L2s that let you run a sequencer, let alone have a second sequencer even operating. And so my concern is if we just focus on software, we're going to get more co-location features, right? Because suddenly if Solana gets faster, right, and now suddenly we're doing 150 million CUs in a block, that's more data. Every time you have to send more data, the public internet has more and more and more of a negative impact on your performance threshold. The public internet's totally great for the Ethereum L1. Plenty fast enough for it, right? The minute you start to try to make Solana faster, suddenly like, oh, well, maybe now it's kind of hard to run a node in Thailand. Maybe Singapore falls off the list of where you can easily run a node, because now it's just Tokyo and Amsterdam. And there's some in New York, right? That, like, Salt Lake City falls off the list. Suddenly, all these places, it doesn't have to get much harder, right? 10 basis points of loss based on where you are is enough to make a validator move. These are very profit-motivated businesses, both the validator side and the MEV side, and they should be. This is what makes them great. But like, if we ignore the physical constraints of the public internet, we're going to end up building a data center chain that runs in one data. This is like, you got to pick your battle, right? It's like you're either on the Hyperliquid trajectory of you've got 11 validators in 2 data centers in Tokyo, or you've got your single sequencer model, or you're actually committed to saying, like, we have to fundamentally do things differently so we can maintain a extremely fast, high-performance chain with multiple concurrent leaders that is globally distributed and has 2,000 nodes running on it.
Yeah, I think it's kind of just like classic Solana abundance mindset
Yeah.
of like, you know, or
Right.
like the old trilemma and everything. It's like, no, it's not a binary where you're just picking a point on the spectrum. Like there's an alternate path. And
the trilemma is solved. Like, Solana solved the trilemma a long time ago, right? And like, if we get the network to a place where it's running on Doublezero or competitors to Doublezero, like private fiber systems that have cryptographic assurances and are run by multiple independent contributors, we're gonna get this thing to a place where it'll run circles around everything else. And I think that's the future everyone wants to live in.
yeah, and I mean, what is personally really exciting to me outside of Doublezero is just core Solana is moving really fast in a really positive direction. I think everyone knows FireDancer and how exciting that is. You know, the timing of that, who knows, maybe later this year. Like, I'm not in the loop on that. But then core Anza is also working really, really hard and doing a lot of very cool stuff. So like, even without FireDancer, like the network is in a very, very good place, and like they're just getting started. And so you have the software layer that is moving so far forward, and then pairing it with Doublezero, and it's like 2 to 3 years out, things are going to be very good, if not sooner. So like, what does that look like to you? Like, what is success for Solana paired with Doublezero in 2027 or 2028 look like?
250,000 TPS as like a baseline. I think it's pretty hard to see us being below that based on the software optimizations and the connectivity optimizations, while maintaining at least 1,000 validator set.
Yeah.
Yeah.
And what is like, I mean, it's just crazy to even reason about it, right?
Right.
So many multiples of what TPS is today. Like, what do you see this opening up that we aren't doing?
Yeah, so this is like the thing. Like, people are always like, why do we need that many TPS? It's like, I have no clue, right? And I'm glad I don't know. That's actually really good. That means innovation's actually like not ahead of what we can actually do yet. No. But like, this is the thing that like, everyone's always like, why do we need faster chains? It's like, okay. Think about this a different way. You had a 2G iPhone. Was that fast enough? No, right? But like, we get to a place very quickly where technology creates opportunities we never thought were possible before. So like no one looked at Steve Jobs launch the iPhone and said this will change dating forever and put taxis out of business. But it like basically did both of those things, and no one could have predicted it. So who knows what we'll get? Maybe Google AdWords will get a competitor that's actually based on crypto, and we'll have cryptographic ads that are running auctions in the time it takes a page to load. Maybe it's entirely new paradigms of how stuff can be built that we haven't thought of before. I think that like one of the only things that we know to be true is base layer performance is always throughout history the limiter on software performance. Right? You would not have gotten the mobile revolution if we were stuck on 2G connectivity. You would not have gotten YouTube or TikTok or Instagram or any of these things if you had to wait 30 seconds for an image to load. And so if we get Solana up to a place where it's doing insane numbers of TPS that no one could imagine demand for. I mean, people said this in the early days of Solana. What the hell do you need 4,000 TPS for? It's like, well, compressed NFTs and meme coins seem like a pretty decent answer to that. But everything always starts off as jokes and toys and non-serious applications, and then this type of stuff starts changing the world.
Yeah, and I think it's just imperative for everyone in this room, everyone in Solana, build apps and find cool use cases to saturate that TPS so we can keep pumping it up, because that's what we really need.
This is like the biggest thing is like if the network is a limiting factor in innovation, the game's up.
Yep.
Which is what happened on other networks, and it's been what they've been dealing with for years at this point is people want to build cool shit, and the physical infrastructure layer just can't support it.
Yeah. So we're up on time, but anything you want to shout out for people that are following Doublezero to, upcoming things they should be aware of?
Yeah, I mean, we've got a testnet up and running, so if you're a Solana validator interested in trying out Doublezero, that's coming. We're looking for mainnet in Q3.
Nice.
So things are coming pretty soon. I would say there's not a ton for folks who are like developers or users to do at the moment. The testnet's really for testing validator systems and those sorts of things, but we're always looking for more connectivity into more countries and high quality bare metal providers for people to be able to host stuff on. So.
All right. Yep. Austin, super accessible. So you know how to find them if you're interested. But thanks everyone for the time, and very exciting. So let's IBRL.
Thanks.